Hello, everybody. I hope you are doing great. Now we are continuing with question number 6. Very important question. I hope you will enjoy it. Let me read out for you. A nitrate solution which contains silver plus 0.005 molar, iron 2 plus 0.01 molar, cadmium 2 plus 0.001 molar, and hydrogen plus 0.001 molar is electrolyzed using platinum electrodes. Hydrogen overvoltage on silver is 0.67 volt, on iron is 0.53 volt, on cadmium 1 volt. Oxygen overvoltage on platinum is 0.65 volt, and standard reduction voltage of the ions are presented below. Question number A, please indicate the sequence of metal deposit on the cathode by making calculations. Here, normally we would conclude that silver starts off with the reduction, then hydrogen, then cadmium, then iron, theoretically speaking. But on the other hand, we need to take hydrogen overvoltage into consideration. This hydrogen overvoltage will change everything. So we need to calculate, we need to make the calculation in order to establish the sequence of the reduction potential. Well, let me sketch it down for you here. This is the concentration of silver. If it is 1 molar, okay, its reduction potential is about 0.8 volt. If we have, for example, 2 molar, so reduction potential increases. If it drops to 0.5 and reduction potential of silver drops to here. And we can calculate this one using Nernst equation based upon concentrations. Using Nernst equation, we can calculate E values. Okay, let's start off with silver. Reduction potential of silver, and minus 0.0592 and number of electrons, and logarithm 1 activity of silver plus. You know, activity of silver plus is equal to concentration, molarity of silver plus. So instead of this one, we can use this one. And silver, you know this value, it is given in the question 0.8 volt or 0.799 volt. Plus, we reverse it. It becomes 0.0592, and this is 1 electron. The valence value is 1, so we don't do anything regarding this. And the concentration of silver nitrate, which is 5 times of 10 to minus 3. When we do calculations, the silver would be 0.662 volt. Okay, while using Nernst equation, this is the Nernst equation, we can calculate its species reduction potential. And similarly, we can calculate E potential for iron, E potential iron standard plus 0.0592. This is 2 electron, and logarithm 10 to minus 2. And you know this value is standard value, 0.44 volt. and iron reduction potential under these circumstances drops to minus 0.499 volt. Why? Because when we decreased here, this is 0.44 volt. If it is 1 molarity, and the molarity in this question 10 to minus 2 molar, and this drops to minus 0.499 volt. Using, again, I'm repeating, again using Nernst equation. And similarly, hydrogen potential can be calculated. This is hydrogen reduction plus 0.0592 and 10 to minus 3. Actually, pH is 3, and reduction potential of hydrogen drops to minus 0.177 volt. And now we come to cadmium. Reduction potential cadmium 2 plus is equal to reduction potential of cadmium in standard value plus 0.0592 divided by the valence electron of cadmium, which is 2, valence number of cadmium 2, and the concentration of cadmium 10 to minus 3. This would be plus minus 0.492 volt. The standard value was 0.403. It drops to 0.492 volt. Okay, now we calculated each of it. And let's include hydrogen over voltage. Normally, it behaves noble, but due to dyskinetic factors like hydrogen over voltage, hydrogen reduction drops. Let me write down so that you can. Hydrogen reduction potential drops, and all of a sudden becomes more active. Let me say more active than cadmium and iron. Initially noble, but due to the kinetic factors, hydrogen reduction potential drops and becomes more active, actually more active than cadmium and iron. Let me calculate. For when it comes to silver, hydrogen reduction becomes 0.177 minus 0.67 equal to 0.847 volt. And for iron, hydrogen reduction potential is minus 0.177 minus 0.53. See, this is hydrogen reduction potential, depends on metals. When it comes to silver, it is 0.67 volt. When it comes to iron, it is 0.53 volt. And when it comes to cadmium, hydrogen reduction potential minus 0.17, 1 volt. Reduction potential becomes 1 volt. And here, minus 1.77 volt. This is minus 0.7 volt. So, silver reduction is 0.633 volt. Cadmium reduction minus 0.492 volt. And iron reduction minus 0.499 volt. And hydrogen reduction, because it starts off with silver reduction, because it's noble metal, chemically inert metal, in terms of electrochemistry. So we need to base on silver reduction, and then hydrogen reduction potential drops to 0.847 volt, because we take this value for, since silver electrodes takes place first. The first, this one starts, and then cadmium, and then iron, and finally hydrogen reduction takes place based on these calculations. So after, let me write down here, after silver reduction finishes, then cadmium electrolysis starts. So we need to take minus 1177 volt into consideration, because here we need to take this value. The first, we take this value for hydrogen reduction because our potential is 0.67 volt, and then when this finishes, it comes to cadmium reduction. When it comes to cadmium reduction, hydrogen reduction potential drops to minus 1.177 volt, and this is the reason I take this one. And after cadmium finishes, then it comes to iron. When it comes to iron reduction, we can calculate the hydrogen reduction, included hydrogen over potential, and it becomes 0.707 volt. Okay, question number B. Please calculate the electrolysis starting voltage. Okay, and when we say electrolysis, this is not a galvanic cell or voltaic cell. We need to supply energy. We need to pay the price. Okay, let's calculate how we can do the calculation. And we know that, ladies and gentlemen, silver starts to be reduced. Okay, and we need to calculate E total is equal to E anode potential, and over voltages takes place in the anode, plus E cathode, and over voltages takes place in cathode compartment. Silver gets one electron to be reduced into metallic form. Now this is value, standard value is plus 0.799 volt. In order to take this electron, something happens. What's going to happen? Hydroxide gives off oxygen gas to form water plus 4 electron. So what's going to happen here? This gives us 4 electron, and these 4 electrons are taken by silver, so that silver reduced into metallic form. And let's calculate, and this takes place in the anodic compartment. Let's remember, where is reduction? There is oxidation. Something is oxidized and the other part is reduced. So there is always an equilibrium. There is always balance, you know. Somebody gives us electron, other guy takes this electron to get the balance. Okay. Here the anode is minus 0401 plus 0592, and the hydroxide ion concentration 10 to minus 11, and this equal to minus 10522 volt, and E anode plus over voltage takes place in the anode compartment, minus 105 volt plus minus 056 volt is equal to minus 17 volt. Okay, and this comes from the question here. It comes from the question, and it says that, as you see here, oxygen over voltage on platinum is 0.65 volt, because platinum is used. In order for oxygen to evolve, you need to pay the price, and this is the price. This is the price. Let me here. This is the price for oxygen to form, and this is 0.65 volt. And this is the voltage takes place in the anodic compartment. Let's look at the cathodic compartment. The cathode, the reduction potential of silver is 0.622 volt plus 0 volt, because there is no voltage for silver to be reduced, so you don't need to pay any price. Okay, then this is plus 0.622 volt, and when we combine them together, E total minus 17 volt comes from in the anodic compartment, and this guy takes place 0.6 takes place in the cathodic compartment. E total is equal to minus 1078 volt. So we need to apply a voltage greater than 1.078 volt, so that the electrolysis can take place. What we infer from this statement is here, this is non-spontaneous reaction. Okay, in order for us to make this non-spontaneous reaction spontaneous reaction, we need to take the price. We need to pay the price. We need to get the ticket. The ticket is here to supply greater than 1.078 volt, so that silver reduction takes place. As silver is a precious metal, it starts off first, and then cadmium starts off, and then iron, then finally hydrogen reduction takes place due to hydrogen over potential. All right, now we come to question number C. What should be the minimum pH level of the solution if iron concentration drops to 10 to minus 7 molar without hydrogen evolution? So from the Nernst equation, it is possible for us to calculate iron reduction potential. If it is 1 molar, iron reduction minus 0.44 44 volt. And if iron reduction drops to 10 to minus 7 molar, E reduction is minus 0.44 volt plus 0.296 volt. Its value is divided by 2 times logarithm 10 to minus 7, and iron reduction drops to, ladies and gentlemen, to minus 0.6472 volts. If it is 1 molar, it was here, and drops to minus 0.6472 volt. And this voltage is equal to hydrogen reduction potential, because the question asks us to do this. 6472 volt is equal to 0.0592 hydrogen ion concentration plus over voltage on iron, which is actually 0.53 volt minus 0.472, and this is plus pH minus 0.53 volt, and the pH value is about 1.979 volt. So pH value would be equal to 2. And when we go back to question number D, as you see here, what should be the electrolysis voltage at the last step? Please calculate. So it says last step, we understand that we reduced silver, we reduced cadmium, we reduced iron. Now finally it comes to hydrogen reduction. It's quite easy to calculate. Total is equal to E anode plus over reduction, over potential, plus E cathode plus over voltage, we calculated actually this value is about to minus 0.647 volt in question number C. E total is equal to minus 1.052 volt plus minus 0.64 volt. This is due to platinum. And it's minus plus minus 0.6472 volt. So E total is equal to minus 2.49 volt. So using, and this is the answer of question number D. As you know, using Nernst equation, we can calculate each species reduction potential. So first silver is reduced, and after that cadmium reduced on the cathode, and then iron precipitates on the cathode, deposits on the cathode, and finally there is no longer iron, or iron concentration drops to minimal level, and then hydrogen reduction takes place. In order for us to run this reaction, we need to supply more energy than this one, because this is negative value, we conclude that this is non-spontaneous reaction. And when we supply, for example, 3 volt, and we can also reduce hydrogen from this aqueous solution. I hope you enjoy this recording. Thank you very much indeed. Take care. Bye-bye.